Okay, today we will have a group project, right? And then you have to identify problem and take a case study using advanced analytical model, where you have to get the data set and provide detailed solution using deep learning in artificial neural network. Okay, you have to provide step by step on how data being analyzed with deep learning techniques. Okay, and as a guide, you can use this cross-industry standard process for data mining, as we have learned in our class. Okay, so now we will have a presentation by group leader and group members. Okay, thank you. Please.
A very good day to all Professor Burhan, and to everyone who is listening. We are Group D from section S2G2, and today we will present our neural network project titled A Deep Learning Approach to Image Classification and a case study on a cat versus dog using CNN. I'm Angelo, and with me are my dedicated team members, which is Fatin, HAZMIE, Nadiah, and FAROUK. Together, we have worked together to bring this project to life. Our project focuses on the fundamental task in the world of AI and computer vision, which is in image classification. The challenge we chose is the well-known cat versus dog problem. While telling a cat from a dog is simple for us, but teaching a machine to do the same is a significant challenge. It requires the machine to learn complex visual features like fur texture, ear shape, and also facial feature and structure. Our objective was to build a complete deep learning model from start to finish. To guide us, we followed the industry standard FRIPS-DM process, which is from understanding the problem and preparing the data all the way to training, evaluating, and finally deploying the model into a working application. Now, to begin the technical detail, I'll pass the floor to HAZMIE, who will walk you through the initial setup of our project.
Thank you, Angelo. Okay, first let's go over the project setup process. We begin by installing Python version 3.11.4 from the official Python website. Next, we install PyCharm, the community edition, which is freely available on the JetBrains website. After that, we follow the default setup instructions. Once installed, we launch PyCharm and create a new project. But during this step, we also set up a virtual environment to keep our dependencies isolated. Finally, in PyCharm, we install the necessary Python libraries for our project. This includes TensorFlow, Pillow, TQDM, and Matplot library. Okay, next. Okay, for this project, we use the cat versus dogs dataset. It was originally provided by the Microsoft Research and available through Kaggle. The dataset contained 25,000 JPEG images, which is an equal split of 50% cats and 50% dogs, all packed in one zip file. However, we did encounter some issues. A few files were either corrupted, incomplete, or non-actual image files. To address this, we cleaned the dataset using a basic laundering process. After cleaning, we ended up with 24,998 usable images for training and validation. Okay, next up, I will pass it to HUSna. Thank you.
Alright, thank you, HAZMIE. For my part, I will be introducing the Python ecosystem for deep learning, the key software tools that power our project. Next. Building a neural network from scratch would be extremely difficult without the right tools. These three libraries, TensorFlow, Keras, and Pillow, gave us the structure and efficiency we needed. First, TensorFlow is our computational engine responsible for the complex math like matrix operations and gradation, the backbone of training any neural network. Next is Keras. While TensorFlow is powerful, it can be hard to work with directly. Keras gives us a simpler, high-level interface to build and train models quickly. So TensorFlow does the heavy lifting, and Keras gives us an easy way to control it. Lastly, Pillow. Deep learning models need clean, consistent image data. So pre-processing, loading, resizing, and formatting image, so they are ready for training. And with that foundation in place, I will now pass it over to FAROUK, who will walk through the core concept of our convolutional neural network.
Thank you, Kasina. So now I'm going to explain how CNNs works. So our model is conventional neural network, or CNN, the gold standard for the image classification. So now I'm going to explain how it works. So first of all, we use conv2d layers. This acts like a feature detector. They scan the image for edge, texture, and pattern like the whiskers or the ear by using learnable filters. Next is max pooling. After each conv layer, we downsample the data to keep the only most important features, and this makes the model faster and more efficient. Next one is the flatter layer. This convert the 2D features maps into the 1D vector, so our final layer can be processed. The last one is dense layer, the brain of the network. The last layer using the sigmoid function for the output and the probability. Let's say 0.87 for dog or 0.12 for cats. We also added dropout layer, so randomly turning off the neurons during the training to prevent overfitting the system. So this help our model generalize better to the new image. So next, now I'm gonna talk about the training pipeline. Our training pipeline follows scripts DM with the heavy focus on the data prep. So now I'm gonna explain step by step. First of all, we use the data laundering. We rebuild the data from scratch, converting every image to RGB and discarding corrupted files. Next one is data argumentation. To teach the data variety, we randomly flip and rotate image during the training. This prevents the memorization. The last one is callbacks. We use model checkpoint to save the best model automatically. And next, reduce LR on the tool to tweak the learning rate if the model got stuck. A validation accuracy of 86%, no crash, thanks to our clean data pipeline. So now I'm going to pass to Nadiah for the implementation and findings.
All right, thank you so much, Farouk. So I will be continuing our presentation with the implementation and findings. So as we can see here, here included is the screenshot of our console output during data laundering process. So what happened during the data laundering process? Firstly, our raw data set caused model crashes due to incompatible image files, meaning that many files were corrupted or unreadable by TensorFlow. So we have to build a custom data laundering pipeline. Our data laundering pipeline will process every image into clean RGB JPEGs in a new folder, meaning that invalid files were automatically discarded, and as a result, we have a 100% clean TensorFlow compatible dataset, crucial for successful training. Next, for our model training and analysis of results, as we can see here, this is the graphs of our training and validation accuracy and training and validation loss. So our training ran for 30 epochs with performance tracked throughout. And as we can see, our accuracy steadily improved, reaching over 85% by the end, and our loss decreased consistently, showing better model performance. We also have a very strong generalization here happen during training and validation accuracy and training and validation loss. Our strong generalization indicates that our model avoided overfitting and generalized well to a new data. Next, I will be passing to Angelo for project demo for the prediction GUI.
Thank you, Nadia. After all the data has been cleaned and trained, the final step in our project was to deploy our model into a practical and more user-friendly application. For this, we developed a GUI which used Python Tkinter library. Our application loads the cat versus dog best model.cras file. This file contains the best version of the model that was saved during the training. It allows us to test it on new image instantly without any retraining. Okay, now let's see with a clear picture of a dog. As you can see, the model correctly predicts that this is a dog. It does so with a very high confidence percentage, which is over 95%. This shows that when the image is clear, our model is very certain about its prediction. But what happens if the model is faced with something more ambiguous? To test this, I will upload an image of a fox which share features with both cats and dogs. This is where our application design for responsible AI comes in. The model predicts that this image is a cat, but you guys notice that the confidence score is much lower, which is around 68%. Because this confidence is below our 70% threshold, the application display a warning, which is a note that stating the model is not very confident about this prediction. This feature is crucial because it honestly communicates the model's own uncertainty to the users. It shows that our system don't just give an answer, but it also provides context on how much that the answer should be trusted or not. With this successful demonstration of our deployed model, I will now pass it back to Nadiah to conclude our presentation.
Thank you so much, Angelo, for the project demo. Now I will be concluding our presentation for today. So in conclusion, our neural network project development has successfully built an end-to-end CNN model to solve the cats versus dog classification problem. We have achieved approximately 87% validation accuracy through structured training and tuning. We have developed a custom data laundry pipeline to align process with the CRISP-DM framework. We have also deployed a model into a GUI app for real-time predictions with confidence feedback. But for our future work of improvements, we would love to explore transfer learning using pre-trained models such as VGG16 or MobileNet. We also aim to push accuracy above 95% through model fine-tuning, and then we would love to enhance the GUI app for broader usability. Before we end our presentation for today, we would love to have a Q&A session. So I have a question that I would like to ask you guys and we can brainstorm together. Okay, my question is, in the results, our model's accuracy was around 87% and not 100%. Could anyone here explain why it doesn't get every answer right? Why the accuracy is not 100%?
Okay, so I want try to answer that question. So why the model doesn't give 100%? It was because the image can be very tricky. Like for an example, a cat might curl in a way that the cat looks like a dog, or maybe the lighting could be bad. And because our model learns from pattern, but some image can be very ambiguous even for a human. Yep, that's my answer.
All right, thank you so much, Angelo, for the answer. So I believe that is all from us. So thank you so much for watching.